Hey y'all, it's your personal math teacher, Mr. Boyden. I'm back at it again, and today we're going to talk about how to do a test for a population proportion. This follows the format of the last two units when we started with sampling distributions. We first learned the concept, then we learned about proportions, then about means, then confidence intervals. We learned the concept, then proportions, then means. Now we're doing significance tests or hypothesis testing, and we learned about the concept. Now we're learning about proportions, and then we're going to learn about means. So these all follow basically the same trajectory. What I have up here at the top of the screen right now is basically what you're supposed to do anytime you get a free response question about this topic. We want to break our answer down into these four categories: state, plan, do, and interpret. And that's really what we're going to be looking at today. The calculator stuff that we're going to do is relatively simple and relatively easy. Sometimes the reading can be hard, and sometimes writing these answers out correctly can be kind of hard. Now, just so you know, it's never going to say on a free response question, do a state plan, do interpret. It's never going to say that. But this is something that you can do to make sure that you hit all of the key points of the rubric. Okay, so if you're taking notes right now, you may want to pause and write some of that stuff down so that you can have it. Okay, let's keep going. Okay, next thing is, we are not going to do these calculations by hand. Okay, we're going to let the calculator do the heavy lifting. And so what I have on the screen here is a screenshot of my calculator. I went into the menu, and then the statistics menu, and then down here you can see I've chosen the stats test. Now remember, this topic we're talking about could be called significance testing or hypothesis testing. That's why we're going down to stats tests. And then we have the list here. So let's think about what we're doing today. In order to understand that, let's think back to what did we do when we were doing confidence intervals? Well, we were up in this menu and we had a 1 proportion z interval, if I recall correctly. And so today what we're learning is going to be a 1 proportion z test. Okay, this is, for today's entire lesson, this is where we're going to be going. Now, in terms of conditions, the conditions that we have to meet, they are, luckily, exactly the same as they were for a confidence interval for a proportion. So what were those three? There were three conditions. Number one, we have to establish that our sampling or our experimental assignment was done randomly. So we have a randomness condition to meet. As always, we need to satisfy the 10% condition. And then the third one, because this is a proportion, so be careful. Central limit theorem, large counts, normality, what is it? This is a proportion, so this is the large counts condition. We will always, anytime, just get in the mindset, do this before using the calculator. So before you even think about touching your calculator, and there's my little calculator, before you even think about touching the calculator, please always do these first. And let's get in that habit today, because if we don't, that could bite us on free response questions later. Okay, there's a note here about the large counts condition. And what this is saying is that in the large counts condition, we use the null value for the proportion. And what that means, we're going to use whatever value we have in the null hypothesis. And with that, we're already ready to look at an example. Okay, here's our first example. A recent report shows that 55% of US adults use Netflix to stream shows and movies. An advertising company believes the proportion of California residents who use Netflix is actually greater than the national proportion because Netflix headquarters is in California. The company selects a random sample of 600 adults from California and finds that 360 of them use Netflix. Is there convincing evidence at the alpha equals 0.05 significance level that more than 55% of California residents use Netflix? All right, so this is a question. They say, is there convincing evidence? And they didn't give us a confidence interval. This is a clue that this is a significance test. Convincing evidence at the alpha equals 0.05 level. Okay, so they're never going to say like, hey, would you please do a significance test and write hypotheses? And this stuff below that I'm putting down, this is scaffolding to help us understand how to answer the question. But that's never going to be given. Okay, so that's something that we have to practice enough that we read the question like this and we recognize, oh, that's a significance test. Okay, that's how we would want to answer that. Okay, so first thing, we're going to do state, plan, do, interpret. We're going to start with the state. We need to name what are the hypotheses and what is the parameter. So null hypothesis, alternative hypothesis. And they said, this is the conventional wisdom up here, the status quo. We're testing against that. So that would be that the proportion, make sure you don't write p hat, y'all, it's a parameter, that the proportion is 0.55. And then what direction are we headed from there? And they said, the company believes the proportion of California residents who use Netflix is greater than, okay, they told us. So we're going to check to see, and we're going to look for evidence that p is greater than 0.55. And then we need to define the parameter. If you do not define the parameter, you're going to get marked down for this section, and that 4 that you were going for just became a 3, so make sure you always do this. Now, guys, for the state plan do and interpret, I've basically listed out what you're supposed to write each time for these, and it's basically the same every time, okay? So you got to look at the question and figure out what is the parameter. The parameter is p, which we are going to define as, what is this? It looks like it might be right here. Is this what it is? The proportion of California residents who use Netflix? Okay, so we need to write that in. And people, don't skimp when you write the parameter, okay? We write the proportion of California residents who use Netflix, write out the whole thing and do it every time. If you don't, you're gonna get dinged. Okay, that's the state. That part is easy. We are already at 1 point on this free response question. Let's go to part 2. What's the test we're using and how do we meet the, and do we meet the conditions? Okay, so I'm gonna write it out like this. Our test, because it's only one sample and it's per proportion, I'm just gonna write out 1 proportion z-test. And then we need our conditions. Condition 1 is the randomness condition. And did we meet that? Let's see. The company selects a random sample. Okay, I'm going to quote them. In quotes, random sample. Okay. Number 2, and put a check at the end. So check, so you're just showing like, hey, grader, hey, AP reader, hey, Mr. Boyden, I checked this and it works. Okay. Next, 10% condition. Let's see if we met the 10% condition. What was our sample size? 600 adults from California was our sample size. So what we're going to say is that we believe that 600 is less than 10% of California residents. Okay, number 3, large counts condition. Okay, so remember we're going to use our null value for the proportion on this. That's 0.55. And so let's do our setup for the large, oh, I forgot to do a check mark, haha. Let's do large counts condition. And large counts condition would go like this. It looks like it would be the sample size of 600 multiplied by 0.55 needs to be greater than or equal to 10. And it needs to be greater than 10 when we use the complementary probability, so 0.45 needs to be greater than or equal to 10 also. I'm going to take a moment here and just punch those out in my calculator. So 600 times 0.55, and that's, wow, it's not even close. So that's 330 is greater than or equal to 10, and 270 greater than or equal to 10. Okay, good. So not even close. Awesome. Okay, we are now at 2 points out of 4 for this free response question. And usually, guys, they break it up into 4 points, state, plan, do, and interpret. There's a point for each on a 4-point free response. Now we get to run the test and find the p-value. There's a couple different ways to do this. You can write them out. One thing that I want to encourage you to do is to draw a picture, because it helps us understand what it means, what these values mean. It also is going to be helpful to us in demonstrating to a grader that we know what we're doing and that we understand what we're doing. So it's time for us to run the test, and that means we're going to need to go to our calculator. In our calculator, we're first going to go to the menu, statistics, because we're doing statistics. We're about to run a test, so I'm going to stats test, and then it's a 1 proportion z test. Remember, before it was an interval, that was for confidence intervals. Now we're doing a significance test. And so we get in here, they're going to ask us for some information. PO, that is the null proportion. That's the thing we're testing against, so that's 0.55. our successes, I'm looking back at the question, we saw that 360 of the people use Netflix out of the sample size of 600. And then we need to let them know what our alternative hypothesis was. So did we have the true proportion being greater than, not equal to, or less than? Look back at what you wrote. We had that the proportion P is greater than the null value. So we do have to make the correct selection there, or the calculator doesn't know what we're doing. And now we get to sit back and let the calculator do the work. And let's see what it says. Okay, so there's my output. Now what does that all mean? They gave us a p-value down here, which is nice. They gave us back our p-hat and our value for n, just so we know. They told us what the alternative hypothesis was so we can check it. The ones that we are interested in are the z and the p-value. So I'm going to come back over and write those down back on my notes over here, back on my question. So they said that z is 2.46, I'm rounding. And they said that p-value is equal to 0.0069. Okay, so what does that mean? Let's fill that in on our picture. What this is saying, remember, this z, and by the way, I want to add something. This will sometimes be called the test statistic. Z. Okay. What that means is on this normal distribution, a standard normal curve, which is centered at 0, our value for z, or our test statistic, is 2.46. And then compare that against what our alternative hypothesis was, that p would be greater than. Okay, and so what we do is we shade to the right over here. And this area right here, that's what the p-value is, 0.0069. Okay, and so what I wrote right here, that actually shows that we know what we're doing. That's enough for full points on the do part. We're now up to 3 points for this free response question. The last question is often the easiest because it always works the exact same way. There are no curveballs in this last part. We have to put what this means in context, and we have to say if we have convincing evidence or not to be able to reject the null hypothesis. So here's where we look. I'm going to go back up to the question and remind myself that they said the level of alpha, the significance level, was 0.05. The end is going to go like this. We're going to say, since the p-value, whoops, I forgot to write since the p-value, which equals 0.0069, is less than alpha, which is 0.05. So guys, double check, make sure you feel very comfortable with that. It's a really small p-value. That's a great p-value. Okay, so since that's true, we reject the null hypothesis. Okay, that first sentence is always going to be just a stat sentence, and then we're also going to write a sentence in context. If you don't put it in context, then they're not giving you full points on this. Okay, so we're going to say we have convincing evidence that, and then if you ever get confused on this, go back up to the state part and look at what you wrote for the parameter. We have convincing evidence that the P, the proportion of California residents who use Netflix, okay, that the proportion of California residents who use Netflix is, all right, now we said we rejected the null, so we go to the alternative then. So we have convincing evidence that that P is greater than, and I'm going to word this last sentence the exact way the question worded it. They want to know if more than 55% of California residents use Netflix. So I'm actually going to put 55 instead of 0.55. So I'm going to put is greater than 55%. Okay, and that, now we explained it in stats, we explained it in context, we've really demonstrated our understanding. This response now would earn all 4 points on a free response. Okay, so with a little bit of practice and a little bit of studying, this is something that we actually can reliably score 4s on every time. There aren't as many curveballs on this type of question as there would be on certain other types of questions, because when you get a question like this, it's very easy to know exactly what the rubric is looking for. Okay, so that's pretty good. That's a test, an AP exam level question on our first example in the video already. Let's continue. Now, the calculator will do most of the work for us, but it's not a bad thing if we understand what the calculator is doing in the background. It's generating that test statistic that we talked about, that z that we used in the previous example. Here's how it does that. It's using what we learned in the very beginning of the year. We learned that this is the definition of a z-score. And I actually copy-pasted this from an earlier video, or earlier lesson if you're in my class. Okay. So what they're filling in, they have the statistic, let's color code this. They have the statistic, which is p hat because it's a proportion. They have the parameter, which is p because we're dealing with proportions. And then they have the standard deviation of the statistic, which we learned 2 units ago would look like this for the sampling distribution of a proportion. So they're just filling those in. Okay, so what would that look like if we filled that in our calculator? So if we actually tried this calculation, because guys, by the way, back before we had these awesome calculators, we had to do this by hand, back in my day. Okay, well, all right, before I go down that road, let's just do it. All right, so our p hat, now remember, the calculator did that for us a minute ago, so we're gonna rely on that. 0.6 minus the proportion we're testing is 0.55. Divide that by this whole thing. And so 0.55 times 0.45, those are those null values, divided by the sample size, which was 600. Let's type that in our calculator. And I want to show you what I got when I did that. I got 2.46183, and I want you to notice up at the top of the calculator screen, that z value up there, that also said 2.46183. Guys, I'm not playing around when I say this is exactly what the calculator is doing in the background. So every time you hit that test button, this is what's happening. And so if you get a chance, you may want to thank your lucky stars that you don't have to do it by hand every time, because that wasn't as fun back in the day when we had to do that. And it's pretty fun to have the calculator just do the work. So we're not done yet. What does that mean? 2.46183. What does it mean? Well, let's sketch that out. What would it mean? It's actually the same sketch we did before on the question. Okay, so over here, 2.46183, because the standard normal curve is over here at 0. And you know what? We're actually going to double check and see what the p-value would be, because based on our hypothesis, or alternative hypothesis, I should say, we're looking for this area. So let me go back to the calculator and let's run this through a normal distribution and let's see what happens. So remember your shortcuts, menu 552 for a CDF. And 2.46183 for my lower bound, infinity for the upper. Let's see what we get for that value. 0.006892. I want you to compare that to the p-value up here above, 0.06912. It's really close. Now, why is it not exact? Well, it's not exact because this number right here is actually probably rounded. So this is rounded a little bit, and so then this one's going to be off by just a little bit. So by having the calculator do all of it, we actually get a more accurate or more precise answer. Now guys, it's really unusual that you have to do one of these by hand. One of the reasons that I'm choosing to demonstrate it in this video today though, is I want to give you a better understanding of what a p-value actually is. And I want you to understand how it's calculated, because if you get what the calculator is doing, then you can understand what it means conceptually a little bit more easily. Because what it is, it actually is a shaded area on the normal distribution. Okay? And this is the sampling distribution, or it's the standardized sampling distribution over here. Okay? So let's answer this question up here. We sketch it on the hypothetical sampling distribution, the hypothetical, assuming that the null is true. Okay, with the null at the center, and then we find the area that represents the alternative hypothesis. That is the p-value. This thing right here that we shaded, that's the p-value, and that's what just came out of our calculator. Okay, let's do another example. Amazon.com offers a Prime membership for a fee, which provides certain benefits. A recent report states that 46% of U.S. households have a Prime membership. We want to know if this proportion is different in Tacoma. We select a random sample of 80 households and find that 43 of them have Amazon Prime. Is there convincing evidence that the proportion of households in Tacoma differ from the claim in the report? All right. Let's do our state, plan, do, interpret. Let's start with our null hypothesis. Our null, we're using a proportion. The claimed value is 46%. So 0.46. The alternative hypothesis. And so automatically we can definitely write down that it's still a proportion. It's still 0.46. And then I gave you a hint right here. This is actually a two-sided test. Okay, now what does that mean? Let's think about what the question asked was. Is there convincing evidence that the proportion of households in Tacoma differ? It didn't ask if it was greater than or less than. They want to know if it's different. It's asking, is it possible that in Tacoma it's not equal to 0.46? So that's how we're going to write our alternative hypothesis. We need to also define our parameter. And you usually can pull it right out of the question down here. Okay, so our parameter is the proportion of, and I'm literally going to just copy paste this, but with my own handwriting, okay? Proportion of households in Tacoma. And I don't want to say differ because I already have that accounted for right here. So I'm going to go back up, and then we want to know if this proportion is different in Tacoma. So it's a proportion of households in Tacoma that have a Prime membership, because that's what the proportion is about. It's about what percentage have a Prime membership. A Prime membership. Okay, 1 point down, 3 to go. Now we need to do the plan. This is a one proportion z-test. And in that one proportion z-test, we have 3 conditions to meet. The first one is we have to establish randomness of the sample, or randomness of the sample. And did we do that? Yep, it says right here, random sample. Quote it. Check. Condition number 2, 10%. Do we have that? Let's see. We can safely say that 80 is less than 10% of Tacoma households. And number 3, large counts condition. So for us, that would be 80 multiplied by, what, 0.46? So 0.46 needs to be greater than or equal to 10. And also 80 multiplied by 0.54, the complementary proportion, the one that would add up to 100 with 0.46, that needs to be greater than or equal to 10 as well. So let's type those in real quick. One on the left is 36.8. Yep, that's definitely greater than 10. And the one on the right is 43.2. which is definitely greater than or equal to 10. There's 2 points down. So isn't that interesting? You can get half the points even if you have no idea how to do anything in the calculator. In fact, let's say, just for fun, let's say your calculator fully died on the AP exam and there's nothing you can do about it. You could definitely get these first 2 right. For the third one, you could actually make up a p-value and then use that made up p-value to do the last one. You can still get 3 out of 4 points even without a calculator on these, which is, it's not advisable, don't do that. And check your calculator the night before your exam, but in theory you could, just so you know. Okay, now we get to actually do the test. So let's go do that. So menu, stats, stats tests, and it's a one proportion z-test. Our null was 0.46. We found that 43 out of 80 houses had membership in Tacoma. And it looks like they already filled in the correct alternative hypothesis. That's luck. That's just the default, by the way. They're going to say it's not equal to. So we're looking at that symbol in the middle right there to make sure it matches, matches our alternative hypothesis. I think I said null hypothesis. Okay, let's see what they say. All right, and here's my results. I have my test statistic, I have my p-value, and they read back p hat and 80. Now, this is interesting. Look at p hat for a second. P hat is 0.5375. We could round that to like 54%. So in our sample, we found that 54% of households in Tacoma have prime, which sounds like it's definitely more than 46% named in the study. Okay, so that sounds like it's really good, but look at our p-value, 0.164. That's big. So what's happening here is our sample size is not big enough for that evidence to be convincing. Okay, so let's take this information back and let's finish out this question. Okay, now the diagram is going to be a little bit different on this one. So the way I'm going to draw this out, we found, because we're always going to put 0 at the middle, we found that the value of z, the standardized test statistic, was I'm rounding here, but 1.39. But remember, this was a two-sided test. It was a not equal to, so it's not just going left, it's not just going right. So what's happening here now is we have 1.39 over here and a 1.39 over here. Excuse me, negative. And then we have both of these areas. And so, what would that be? That would be our total p-value, and our p-value was 0.164. Okay, so 3 is done. Let's interpret that result. Now I want to go back. Did they give us a significance level? Did they tell us alpha in this question? They didn't. That's okay. If they don't tell us alpha, we are going to make an assumption that they want us to use 0.05 for alpha. So let's practice writing out that final interpretation. Since the p-value, which is equal to 0.164, is greater than alpha, which we're going to assume to be 0.05 since they didn't tell us, we fail to reject the null hypothesis. Okay, now, what does that mean? And so we're going to pause here. So we were talking about how to write the answer. Let's pause and say, okay, hold on, what does that actually mean? Does that mean that the null hypothesis is true? No, not at all. In fact, we found that p hat was something like 0.54. So if you find that p hat is 0.54, then we actually do have some evidence because it was claimed to be 0.46 and we found some evidence that it's bigger than that. The problem is that according to our p-value, it's not convincing. So we are not saying that the null hypothesis is true. What we're saying is we don't have enough evidence to say that the alternative hypothesis is true. Okay, so let's finish this answer. I'm just going to say we do not have convincing evidence that, and now it has to be in context, right? So we do not have convincing evidence that the proportion of houses in Tacoma, or households in Tacoma with prime is greater than 46%. Okay, now we do have some evidence, okay, but specifically we do not have convincing evidence. Okay, we talked about that right here. So sometimes we would say something like, while we do have some evidence that the proportion of households in Tacoma with prime is greater than 46%, based on this p-value, we do not have convincing evidence of that fact. All right, final note before we end today. I do want to let you know a little bit about AP scoring. Okay, when you do that interpretation, you can never say anything about the null being true, and that's kind of what I was talking about a minute ago. Even when we fail to reject, that does not mean the null hypothesis is true. You can either, and this I'm going to highlight what the language is here, okay? You can either reject or you can fail to reject, like how we said guilty or not guilty in the previous video, but you can never accept the null, okay? Never can you accept the null. if you even hint that you think the null is true, you're going to lose a point on your free response question. So if you could do everything perfectly, but if you say something about how the null is true, your 4 just became a 3. Okay, so please don't do that. Okay, and so what that basically means, a significance test can never provide evidence in favor of the null hypothesis. A confidence interval can show that it's plausible. So if you have a confidence interval from A to B, which contains, the null value of P somewhere in there, that would allow you to say, hey, I think that that null value is plausible, but it's not strong evidence, and it doesn't tell you, oh, yes, it's true. It basically tells you that it's not definitely wrong, or not with 95 or whatever % certainty that it's wrong. Okay, so guys, once you get good at these, they're pretty cookie cutter. Okay, and they're once you study, they're relatively easy to score well on every single time. So it's time to get out there and practice. I think that's enough for today. I hope you enjoyed the video, and I'll see you next time.